Welcome to homework.
So let the EMF of the solar cell be E and the output voltage be V. So we can write the output voltage to be EMF minus current times the internal resistance. So this is the voltage drop, this is the EMF, and this is the output voltage. And current is given by Ohm's law, and that is equal to voltage over the external resistance. So we put plug that in place of current times R, small r, which is the internal resistance. And this equation is followed for both the cases. So substituting the values for both cases, we get 0.1 volt to be equal to EMF minus 0.1 volt over 500 ohms. So this is the value of current times small r. And then for the second case, we have 0.15 volt for the output voltage. That's equal to EMF minus 0.15 volt over the external resistance times the internal resistance. And make sure that use the same notation for EMF and internal resistance, because these two are constants, or these two are the same for both the cases. So basically we are using the same battery for both the cases, therefore they have the same EMF and the same internal resistance. So now we have two equations and two unknowns. So by method of elimination and substitution, we can solve for EMF and the internal resistance. So doing that, we get the value of internal resistance to be 10 to the power 3 ohms, the EMF to be 0.3 volts. So these two values we found by solving these two equations. Now for the third part, we have to find the efficiency. So efficiency given by this notation eta is equal to the power output over the power input or the power received. So let's plug the values. So for power output, we should have the output voltage, which is 0.15 volt over over the resistance, which is 1000 ohms. So we have to take the square of the voltage. I forgot to write that. And then we have power received, and that is equal to 2 times 10 to the power minus 3 watt per centimeter square. So this is the power per surface area. So we multiply that with the area, and that is 5 centimeter square in order to get the total power received. And solving this, we get eta to be 2.3 times 10 to the power minus 3. So in order to find the efficiency in terms of percentage, we multiply this by we multiply this with 100, and we get the percentage efficiency to be 0.23%.